The sun's energy can be used very effectively for space or water heating. Today we'll focus on solar water heaters and how effective they are at meeting hot water demand. Water use accounts for around 6% of carbon emissions in the UK, and around 90% of this is from hot water. In many climates, a solar heated system can provide up to 85% of domestic hot water. In the UK, a bit less than that, but up to 50% of hot water used can be provided by solar energy if we install a 3 metre squared collector. Research by the Energy Saving Trust revealed that £28 million a year could be saved if every house in Scotland had a solar water heater fitted. Not only could money be saved, but also resources. If you have 3 gallons of oil, you can either refine and burn it, producing 400,000 British thermal units once, and then it's gone. Or you can use that same 3 gallons of oil equivalent to make a 4 by 12 foot solar collector, which will produce 10 million British thermal units each year, every year, year after year. Solar water heating technology has been used for a long time. The first solar water heaters in the 18th century were simply metal tanks filled with water and painted black. The first commercial solar water heater was patented in 1891, and the concept of using free energy from the sun to heat water to very high temperatures has not changed. However, the technology involved has grown rapidly more efficient and affordable. I'm in one of Edinburgh Napier University's energy labs with Dr. Celine Garnier, who specialises in integrated collector solar water heaters. She's worked at the university as a lecturer and as a researcher in the Scottish Energy Centre for the last 2 years. She's recently finished a PhD in solar water heating in Scotland. Celine, could you tell us first a little bit about evacuated collector solar water heaters?
Yeah, so evacuated tubes are one type of solar water heaters amongst other types of solar water heaters, such as flat plate collector or integrated collector storage solar water heaters like we have here. Now, this type of collectors work. There is a set of tubes. Each tube is made of a double glass wool layer, with the inner layer having an absorbent coating and a reflective coating, so basically trapping the solar energy and the sun radiation and passing them through. Now, within each of these tubes, the air is removed, which creates a vacuum, which is a great insulator as such. And within each of these tubes, where the air is removed, you got a sealed copper pipe. Within each of these copper pipe, you got an antifreeze liquid, which basically goes down and then warms out, rise up, and then goes to the top of the copper pipe, where the heat is exchanged with another antifreeze going in the header pipe. This antifreeze goes to your systems and then transfers the heat to your water tank.
Right, and can solar energy be used to heat water in Scotland?
Yeah, definitely. Well, your system has to be well designed and designed especially to withstand, specific, basically, weather conditions. So, for example, in Scotland, you'll try to minimize plumbing as such to decrease, heat losses as such. Other ways of improving the efficiency of your collector would be to withdraw, hot water regularly, so you keep, the most efficient use, basically, of your collector.
Right. Your recent PhD focused on integrated collector solar water heaters. Could you tell us a bit about them?
Yeah. Well, that's one, as I said earlier on. That's one of them. We had 2, so one aluminium and one stainless steel collector. The main principle of integrated collector storage solar water heaters are that the solar collector, where you basically cap the heat, and the water tank, so the hot water tank, when you will store the heat, are combined in a single unit. So that's the main, really, driving force of this type of collectors. Now, you can see here, for example, we got the absorber plate, which is this black surface. Now, the solar radiation normally passes through a glazing, which is part of this unit, and hits the absorber plate. Now, this black surface will just absorb the heat and then transfer it to the water, which is inside. Then this water heats up, builds up. This tank keeps the water in and then is drawn off to your system. Another thing is, for example, these ones have fins within it, so this basically transfers the heat through the water within the actual collector. Also, a very, very important parameter for any type of collectors, really. The insulation is an essential parameter within it. This one has insulation at the bottom part, on all the sides as well. This is to decrease, basically, the heat losses, to improve obviously the energy you will produce from your collector. And we also have this wooden box where we basically sit the collector, and this again is to protect it from weather and temperatures and weather conditions, especially in Scotland.
Yeah. How many kilowatt hours are produced in a year?
From the aluminium one, we were producing about 1,100 kilowatt hour annually.
And so could one of these meet the needs of a family home?
Yeah, well, yeah. I mean, partially. Like any type of collectors, it will only partially fulfill the requirements. This type of collectors, again, if we have a 3-person house, we'll be able to get about 40%. A 3-person house, 150 liters of water, about 2,700 kilowatt hours will be required annually. And these aluminium collectors will provide 40.5% of the energy required.
How do they compare with systems that don't have an integrated collector?
Yeah, well, that's a bit tricky because at the moment, as I say, a proper comparison is quite hard to make because this is still a prototype. So as a prototype, you know, it's hard to compare it. But again, you know, all the testing that we've went through showed that they had a lot of future potential.
Now, often I've seen signs that say danger hot water, particularly on evacuated tube collectors. How hot does the water actually get, particularly in Scotland?
But if you think that this type of collectors on a typical Scottish summer day, right, which isn't that great, but on a typical Scottish summer day, this type of collectors will achieve 65 degrees, about. The evacuated tube will achieve higher temperature, also about maybe 100 degrees. It really depends, but again, about 100 degrees for a typical Scottish.
And that's Celsius?
Summer day, Celsius.
I believe that the materials that you use and the actual design of the collector itself make a difference.
Yes, it does. I mean, the material first, as such, makes a massive difference, especially for the absorber plate, as it will very much influence how much heat will be transferred to your water. Now, as I said, you know, we had an aluminium and a stainless steel. So as a good example, the aluminium, using aluminium compared to stainless steel increased the overall efficiency of these collectors by 6%, which is quite significant. Now, for the design part, it's also very important. I told you before we had some fins within it. Using fins increased the heat transfer to the water by 18%. So there is a massive influence through it. The design as well, you know, not neglecting the importance of insulation, because insulation obviously will decrease, you know, the heat losses to the surroundings environment. And who says, you know, decrease of heat losses means more energy produced, which means higher energy and CO2 payback time, and therefore potentially enormous, you know, energy and monetary savings for the actual customer.